let's look at some quadratic equations. So, quadratic equation, well, obviously it's an equation, it's got an equal sign, but it's got a variable to the power of 2. Okay, which means you're going to have multiple solutions, 2 solutions. And generally speaking, when we're solving a quadratic equation, we're always going to be trying to set it equal to 0. Okay, and then we're going to factor whatever remains on the left side. And let's take a look at some of these. So anytime, so this one's already set to 0 for us, but let's imagine we all know how to do that. Let's get everything to the left side or right side. This is a trinomial. It's got 3 terms: descending order, second power, first power, and that's really like x to the 0 right there. So notice the leading coefficient here is a positive 1. So when it looks like this, generally it breaks up into 2 binomials. You know, binomials has got 2 terms, right? And we get 2 of them, 2 binomials. So essentially, you know, we ask ourselves, what times what gets us x squared? Well, it's just x and x. What 2 numbers, when I multiply them together, make a negative 14? So when I add them, make a 5. Okay, so, you know, something like that. You know, I'm sure you guys are good at this by now, but factors of 14 are 1 and 14, 2 and 7, and that's it. So if you wanted to experiment with 1 and 14, yeah, those work, but they don't add up to 5, so you got to keep going, keep trying those out. So then you have x plus 7, quantity x plus 7 times quantity x minus 2 equals 0. So the only way that could ever be true is if the thing in here, if that was 0, okay, because 0 times anything is 0, right? If this was 0 in the green, 0 times anything is 0. So what we do is we take that whatever's in that parentheses there, and so we would do, when is it that x plus 7 equals 0? We solve for x. X would equal negative 7. Okay, so that's where the first solution comes from. And then we ask ourselves, when is it that x minus 2 equals 0? Because if this whole thing was 0, anything times 0 is going to be 0. So that's when we find that out. When is it that x minus 2 is equal to 0? We solve for x. That's when x is equal to 2. So we get our 2 solutions of 2 and negative 7. In other words, if we plugged in a 2 right here, 2 squared plus 5 times 2 minus 14, well, that's 0. Or if we plugged in a negative 7, we would also get 0. Okay. Number 2 here. Okay, remember we've got a quadratic, so first thing I'm thinking, I'm going to try to get this thing set equal to 0. Which side do we want to bring the x's to? Well, let's bring them all to the left. I want to have this x squared term to be positive 1, the coefficient. So we subtract 4x from both sides. Now we're equal to 0. And then you're essentially factoring. Okay, so when I'm factoring, the first thing I always look for is the greatest common factor, or GCF. I look at this first term and I look at the second term and I say, well, what do they have in common? What's the greatest common factor they both have? Well, the coefficient here is 1, coefficient here is 4, so I can't do anything with the coefficients, but this has 2 x's and this has 1 x, so I can factor out an x. X times what gets me x squared? X. X times what gets me a negative 4x? Well, negative 4. And then, just like before, we ask ourselves, what would this have to be in order for this whole thing to be 0? Well, 0, right? Because 0 times anything would be 0, so that's why x could be 0. Or, what's another possibility? Well, just like before, let's figure out when this thing in parentheses would be 0, right? Because if this was 0, 0 times any number would be 0, okay? So when is it that x minus 4 equals 0? Solve for x. That's when x is equal to 4. So our two solutions would be 0 and 4. So another quadratic here for number 3. Okay, got a nice positive coefficient from x squared term. Now you notice it doesn't equal 0 right off the bat. So I got to subtract negative 42x from the right and from the left side. And then I read it in descending order. So we got our squared term, then our x to the first term, and then our x to the 0 term. Now it's equal to 0. So this is not as easy as our first problem because the leading coefficient is a number that's not 1 essentially. So what I like to do, so you could do a guess and check, right? You could play around with some numbers and come up with this. Okay, that's a possibility. And if you're good at that, I'd say go for it. But when you use the shoot 'em up method, it takes a certain amount of time each time, and it's kind of, when you're taking a time test, I would certainly use this method. So shoot 'em up, what is it? Okay, well you take the coefficient here in your last term there, and they say you shoot them up. In other words, you're going to multiply them together. So that's what we did over here. We got our 5 times 16. What does that equal? 80. The next thing we ask ourselves is, what are two factors of 80 that when I multiply them together make a positive 80, and when I add them are going to add up to this middle term here. So negative 42. So you start playing around with some factors of 80, 80 and 1, okay, yeah, but 80 and 1 do not add up to a negative 42. So you keep playing around with them, and then we figured out it was negative 40 and negative 2. Now you might say, well, why are they both negative? Well, yeah, positive 40 and a positive 2 would add up to an 80. Remember, this number and this number need to add up to the middle number here, a negative 42. So, you know, it's got to be, basically it's got to be two negatives. Right when I saw this as negative, I knew that these two numbers both had to be negative. Because how can I have two positive numbers add up to a negative? So that means they both got to be negative. Because the only way to get a positive number here is if I multiply two positives or two negatives. Okay, and then all you're essentially doing from there on out is you're going to rewrite that middle term using those two numbers you just found. So essentially we're rewriting this first step as the second step here, but negative 42x, we're just going to break up into a negative 40x and a negative 2x. Basically just the two factors we found for 80. And then we need to factor by grouping. So when you factor by grouping, essentially what you're doing is you're splitting up the problem in two. Okay, so just looking over here on the left side now, I'm going to factor that out. I'm just going to look for a GCF. What is the greatest common factor of a 5x squared and a negative 40x? Well, look at my coefficients first. What's the biggest number that 5 and a, well, basically what's the biggest number that I can take out of a 5 and a 40? Well, the answer is 5, so that's where the 5 goes. And how about an x squared and an x? Well, they both have a x in common. So I factored out a 5x, and then I say, well, 5x times what gets me 5x squared? Well, I'm missing an x, because 5x times x is 5x squared. And then 5x times what gets me a negative 40x? Well, that's got to be a negative 8. Okay? Now I look on the right side of the equation over here. I need to, what can I factor out of a 2x, negative 2x, and a positive 16? So when you're doing factoring by grouping, you want these two things to be exactly the same, and you're going to see why in a moment. So the next question is, well, I'm looking at this right here, the negative 2x and the 16. and I know the biggest thing I can take out is a 2. Now you always got to ask yourself with the second part here, do I take a negative or a positive out? Well, if I took a positive 2 out, this would be a negative x and this would be a positive 8. So you'd see that these would be similar but not identical. Okay, we need them to be identical. So I experiment a little bit. I say, well, what if I took a negative 2 out instead? Well, that would turn this into a positive x and this into a negative 8. And that's exactly what we're looking for. So now, if you look at the next line, you can see that essentially, this right here and this right here have something in common. What do they have in common? They have an x minus 8. So essentially what we're doing is we're going to factor out an x minus 8. And then I say, okay, well, x minus 8 times what would get me all of this? Well, I need a 5x. And then I say, okay, well, x minus 8 times what would get me all of this right here? And that would be a negative 2. Okay? So really all you're really doing is the thing that kind of repeats itself, that goes out front, and then you multiply it by whatever these two things are. That's where this came from right here. 5x minus 2. And now if x minus 8, quantity x minus 8 times quantity 5x minus 2 equals 0, we know either this is 0 or this is 0, right? So when is it that x minus 8 equals 0? Well, that's when x would be 8. And when is it that 5x minus 2 equals 0? So maybe you can't see that right away, so I'll do it off to the side here. When is it that 5x minus 2 is equal to 0? Well, let's solve for x and find out. So we get 5x is equal to 2. Divide both sides by 5. X would have to equal 2/5. So in other words, if I plugged in if x was 2/5, this whole thing would be 0. Okay? So then our two solutions would be 8 and 2/5. So now it says solve using the quadratic formula. So you are just going to have to memorize this bad boy right here. So what does all this mean? What does the A, B, and C mean? Well, if you look at I think it's called the general form, the quadratic equation, it is, what do we got? Ax squared plus bx plus c equals 0. And all it really says is that the leading coefficient on the x squared term is your a. The leading coefficient on the x term is b, and the leading coefficient, or I guess thus the constant, is we'll call c. Okay, straight up number. So if you're looking at the equation we're given here, what is our a term? Well, that's the 2. What is our b term? Well, that's going to be a negative 8. Don't forget that negative. And what about our constant? Okay, that's 3. Now you notice this form right here has it all equal to 0, so you can't find your a, your b, and your c until you have it all set equal to 0. So that'd be your first thing. And then once you know that, it's really just a plug and chug. So this is our quadratic formula, you just got to memorize it. Negative b plus or minus square root of b squared minus 4ac all over 2a. Notice it's not just this part that's divided by 2a, but the entire thing. Okay. So we need to take the opposite of b. Well, what's our b here? Our b is a negative 8. What's the opposite of a negative 8? Positive 8. Plus or minus b squared. So what is negative 8 times negative 8? So important here to remember. So I'm doing something wrong here. Maybe you can tell me what it is. If I wanted to find b squared, some people are going to do this. Negative 8 squared, they type it in a calculator and they get negative 64. But how could I ever square some number and ever get a negative number in return? Okay, so what they did wrong was they didn't put this in parentheses. We want to square the entire thing. We want a negative 8 times a negative 8. So that's going to be a positive 64. Okay, so that's why that's positive. Anytime I square a number, it's got to be positive. Then minus 4 times a, which is 2, times c, which is negative 3. All divided by 2 times 2. Okay, now I start to simplify. 64 minus a 4 times 2 times negative 3. Well, these two negatives are going to turn to a positive since this is all multiplication. 4 times 2 times 3 is going to be 24. Notice this is all under the square root. And then okay, 64 plus 24 is 88. Now, how do you break up the square root of 88? Well, you ask yourself, are there any perfect squares in 88? And it turns out there is 4. So this is just a property of radicals you should know by now. What is the square root of, so basically the square root of 88 can be broken up into the square root of 4 times the square root of 22. But we know what the square root of 4 is. That's just a straight up 2. It's going to come on the outside. So that's where that came in. And then there's one last step. It said, direction set to simplify as much as you can. So this essentially says, this basically says 8 plus or minus, so 2 root 22 over 4. So that's basically, I mean, whenever you have multiple terms on top, all divided by a single term right here, okay, basically this 8 is getting divided by the 4. This term right here is also getting divided by a 4. So, what is 8 divided by 4? Well, basically, well, what you need to do in this case is ask yourself, look at these three terms right here. So we got an 8, a 2, and a 4. You know, what number essentially goes into all three of those? Well, the answer is a 2. How many times does 2 go into 8? 4 times. How many times does 2 go into 2? 1 time. How many times does 2 go into 4? 2 times. And then this would be your final answer. So, that is all. Godspeed.